Alright, so for this question, they ask you to find the center of mass and the mass with the given equations. So first I'm going to draw out the equations they give you. So you have, I'm going to leave this for last. I'm going to draw out the lines first. So y equal to 0, so you have the x-axis right here. X equal to 1, so x equal to 1, so a horizontal at 1. And then x equal to 3. So now you have a line of like a curve of 2 over x. So it's gonna look something like this. Very bad drawing, but you get the point. Okay, something like that. Alright, and then this is your y equal to 2 over x. And they ask you to find the center of mass somewhere right here. So alright, so you're gonna have to find a mass first. The mass gonna be the r, the base region of k x squared, or your p, or your rho, respect to dy dx, or dx dy, whichever more easier. Alright, so now you have we're gonna do dy dx, so you have a horizontal or vertical rectangle right here from 1 to 3, so you know that your dx, your x bound from 1 to 3, and your y bound is from 0, this is 0, to all the way in the top here, somewhere right here. This is your line, so it's 2 over x, and then your rho is k x squared dy dx, and this is your mass. So we're gonna find the mass. You can solve this by integrating the inside first. We're gonna integrate the inside first, so m is equal to, I'm gonna organize this, so m is equal to integral from 1 to 3. So respect to y, so kx squared y, treat this whole thing as a constant, respect to y. So from 0 to 2x, 2 over x dx. Now you would get integral from 1 to 3. If you plug in 2x, you would get k x squared 2 over x minus 0. This whole thing is going to be 0. If you plug in 0 for y dx, you would get integral from 1 to 3 kx 2 dx. So you can pull out a 2 in the front, so you would get integral from 1 to 3, put a 2 in the front, so kx dx. Now it's very easy, very straightforward. So 2 integral, not integral, your antiderivative will be kx squared over 2, so the 2 cancel right here from 1 to 3. So you would get kx squared from 1 to 3. So you would get k3 squared minus k1 squared. You would get 9k minus 1k, 8k. So this is your mass. This is your mass. Alright, now let's find the center of mass by finding the moment at x and moment of y. So x bar will be moment of y over the mass. So the moment of y will be integral, the same bound. You have the same bound from 1 to 3, 0 to 2 over x. Let me just separate this. All right, and now all you have to do is just add an x when you evaluate the moment of y, and then just add an y when you're trying to find the moment of x. So k x squared, this is your row. You add an extra x into it, and then respect to x. All right, so now this will become integral from 1 to 3, integral from 0 to 2 over x, k x cubed dy dx. Same thing if you is the same way you evaluate your mass. So if you just do the integral, you would get the moment of y will be 52 over 3 k, and then the moment of x will be from integral from 1 to 3, 0 to 2 over x, kx squared, this is your row, and add in an extra y, and dy dx. Alright, and then now this will become 4k. Now you have the my and the mx. Now all you have to do is find the x bar and the y bar by dividing my and mx by the mass. So the x bar will be my divided by mass, will be 52 over 3 k, divided by the mass is 8k. You will get 13 over 6, and your y bar will be mx divided by m, so 4k divided by 8k be 1/2. So now you have the x bar and the y bar. This is your answer. So x bar, y bar, your center of mass will be 13 over 6 and 1 over 2.